He's a climate scientist at the Geography Department of the University of Toronto. He's a co-author of reports by the Intergovernmental Panel on Climate Change. He's written 2 textbooks on climate science and numerous articles, particularly on clean energy issues. So Danny, please continue.
Okay, thank you. So I take it now that my screen is showing?
Yes.
Okay, good. Wait a sec. Okay, so as Richard said, I want to just give a quick overview of the IPCC projections and what the world collectively needs to do. We saw from Ali's presentation that, you know, Canada had a pretty impressive set of promises with strongly downward tracking promises, but the reality has been emissions have continued to track up or just barely remain stable in spite of the downward tracking promises. So what I want to show now is what do we actually need to do and how does that compare with our promises? So I'm showing here the temperature estimates as calculated by various climate models for what are called the shared socioeconomic pathways scenarios. And these are labeled like SSP1, the 1.9, the 2.6, and so on. These numbers are referring to the heat trapping from greenhouse gases and other anthropogenic factors in watts per square meter. So it's really it's a measure of how much greenhouse gases have increased. So what you can see is this turquoise one, if my SSP 1.9 is pretty much plateauing at the 1.5 degrees above pre-industrial, and the 2.6 is plateauing pretty much at the 2 degrees above pre-industrial. Now, these are middle estimates. There's actually a considerable range of uncertainty associated with each of these. So, you know, there's a 50% chance that it's actually greater than 2 degrees or a 50% chance that it's lower within some bound. But anyway, those are 2 scenarios that are at least mid-range, are compliant with the 1.5 and the 2 degree targets. So now let's see what the actual emissions need to be to comply with that. So here are the global greenhouse gas CO2 emissions. So this would be fossil fuel plus land use. And you could see to be on track for the SSP 1.9, which is roughly compliant with the 1.5, we need to go to net zero by 2055 or so. And for the 2 degree target, we need to go to net zero by 2075 or so. And net zero means we could have a small residual fossil fuel emission, but it would have to be offset by some negative emission, the most viable one being a carbon sink through reforestation, which first means we first have to end deforestation. Now, in terms of methane, you can see that the 1.5 scenario requires about a 55% cut by 2050 and a 75% cut or so part CO2 by 2055 to 2075, and various cuts for methane and CO2. Here is the breakdown of the emissions. So for CO2, you can see coal, it has the largest share, followed closely behind by oil and then natural gas. Land use, which is primarily deforestation, is coming in at a quite substantial 15%, and about a third of that would be related to agriculture, animal agriculture related. For methane, the single largest factor is cattle. The oil and gas and fossil fuel industry is about 40%. And this, of course, was the subject of some recent agreements, but, you know, agriculture and animal agriculture in particular is an important part of the puzzle. And then finally, for N2O, which we need to cut by about 25%, agriculture, primarily fertilizer use, is responsible for half. So that's it. That's the sort of the broad overview of where we need to be going collectively, globally, in the next 30 years for 2050 and by the end of the century. Thank you.